Right, so this is a sample data set and we'll try and build some classification trees with this. So here age is young, middle age and senior, income high, medium and low, student yes or no, boolean variable, credit rating fair or excellent, okay, and this is the target variable which we want to predict whether the person will buy a computer or not. Right, so the first way we'll work on this problem is using entropy measure and a multi-way split. Okay. So let's take so what is the first step in building a decision tree? So we have to select which of among the, so this is our target, right? So we don't consider this. We have these 4 attributes. Which one should we pick? In a multi-way split, as we just saw, there is no issue in picking split points, right? So we just need to fix on which attribute to select. So how do we do this? So we'll use the entropy measure. So right. So if we start with the attribute age, so first of all we see how many data points have the value youth, 1, 2, 3, 4, 5, and what are the corresponding class labels? So 2 have no, and the remaining 3 just a minute. So we have 3 no's and 2 yes, right? So how we just apply this formula. So we have so we're calculating cross entropy for the variable age for this data set. So we have is this clear? Yes. Somebody had a question?
What are the attributes in the credit rating?
It's fair and excellent. Okay. It really doesn't matter. I mean, the data set is pretty generic. It's just a toy example, right? So this is the applying the cross entropy formula, but we have 3 different values, right? So we have when we are trying to calculate the entropy, this particular formula is applicable for when we consider one region. Remember, M is the region, right? But when you consider the decision tree, it will be split into 3 different regions, and we want to calculate the overall entropy, right? So this is for the youth. Then we will have to add to that what we will get for middle aged and what we will get for senior. So if you can just add that, do that. So if you look at middle aged, you have 1 is yes, 2 is yes, 3 and 4 both are yes, right? So what will be the entropy? Do we need to calculate this, right? Plus for the senior, and while we are doing this, we also have to weight it according to the number of data points that go down that branch of the tree, right? So in this case, there are 14 points, of which youth there were 5. So we'll have 5 by 14. And for middle age, it doesn't matter, but there are 4 points, and for the remaining it's 5 by 14. So how many are there for senior, if you can calculate that? We have 1, 2, yes, no, same 3 and 2 split, right? So we'll have is this okay? So can somebody calculate this and tell me the value? there any questions with this? Please, you can.
Are you getting that 2 by 5, 3 by 5?
How am I getting?
No, what are you using to get 2 by 5, 3
So
by
you,
5?
so you look at, let's say, youth, right? So that's one particular value, and how many of them are labeled no and how many of them are labeled yes? Two are labeled yes and 3 are labeled no, right? So you are applying this formula, right? So what does this mean? In class region, what is the probability of that this attribute will have a class, a particular class, right? So in this case, with 2 by 5 probability, data point labeled with youth will.
5 youth, there are 2 yes.
Yeah, that's essentially right. So has somebody calculated this value? Can somebody tell me? Yeah. We went through that.
What is the cross part here?
Okay. So essentially, this should be the actual distribution of the data, right? The true distribution of the data, right? So if you knew the process that was generating the data points, then you could. Then this is where you would use that. Like, if the age is youth, then what is the true probability of that data point being classified as yes or no, right? And here we have an estimate which we can use, right? The estimate is going to be off from the true distribution, right? So that's why we are calling it cross entropy. However, we do not know the true distribution, right? So in its place, we are using an unbiased estimator, which is the sample average, right? That's why even though we are using, it seems more like an entropy formula than a cross entropy formula. It is, the notion is actually cross entropy. There is supposed to be a true distribution which would which we are supposed to use, right? Anybody with this value? Come on, guys. 0.693. Right. So next, so this is the entropy we will get when we use the attribute as the root, right? So we can make a decision tree, have age as the root attribute which we test on, and this is the entropy we will get. So next what we do is we do the same process and we try and find the entropy when we use the attribute income, student and credit rating. Is that clear? So can maybe one row can go ahead and calculate it for income and the other rows can calculate it for the other two, student and credit rating. Same calculation, follow the same pattern. I'll give you about a few minutes. Can you go ahead and do the calculation? Important point is that you will get some values for entropy, and which one will you select? The one which has the highest or the lowest? The lowest, because it's a measure of impurity and we want to eliminate that. So in this particular case, you will find out when you do this calculation that this is the best attribute to use. So in your decision tree, you will have at the root age, and you will split in 3 directions, whether it is youth, middle age or senior, right? Now what happens here? So at each of these, once you have done this, it's a recursive process. Now you eliminate from your data set everything which doesn't have age is equal to youth. So you consider only that portion where age is equal to youth, and you repeat the process, right? Yeah. So we've selected the attribute at the root to be age. So now we have this partial tree. So at this point what do we do? Already we have used up the attribute age, so we are remaining with 3 more attributes, but in this branch we consider only those data points where age is equals to youth, and we apply the same process, right, to select the next variable, right. So this whole process is continued, and it goes on up to either you can build the entire tree where each leaf is pure, or you can stop at one point, and then what do you do if it's not pure? You select, you give it that label which is majority, right. Is that clear? So the same process you can do with the Gini index, right. It's just a different formula that you have to apply, but the entire process is exactly the same, where you will instead of using this formula, you will use the formula for the Gini index. Now the next thing we will look at, so this is the case where we actually wanted multi-way splits, but what happens when we want to restrict ourselves to binary trees, right. We looked at some advantages of why we would require binary trees. So in this case what we do is, let us say okay, the same can be done with the Gini index. I will just continue with the gain ratio formula, cross entropy formula. So again, if we want to build a tree, a binary tree this time, we still have to figure out which variable to choose, but in addition we have to figure out split points. So just now we saw how to avoid the problem of, right. So we order the variables. If it is a, for example, a student is a yes or no, it's a binary variable, so there is only one split point. But in the other case where there are more than 2 possible values for an attribute, you have to figure out the split point. So let's do it for this age variable. So you have 5 data points which have age is equals to youth, and out of them only 2 have the positive class label, right. So that's for you So for middle age we just saw that all data points which have age is equal to middle age are classified as yes. So here the probability is 1, and for senior it's 3 by 5. So our ordering will be right. So essentially either we have a split point where we consider youth in one set and senior and middle age in another, or we do this. Now note that this particular attribute age has a notion of order, right. You consider youth, middle age and senior, there is some order, but in this for this exercise we have treated it as a unordered variable, right. If you wanted to use the inherent notion, you would just use youth, middle age and senior, right. So now what we do is the same process, but now we consider all data points lying in youth as well. For example, to start off with, let's evaluate this. So we will do cross entropy right. So here we are looking at the data, we are trying to split the data in terms of a binary split, where on one branch we have age equal to youth and the other branch is age equal to senior or middle age, and we will try to find the cross entropy. So in the previous case, because we didn't have to find split points, we could evaluate the cross entropy once for each attribute, but here we will have to do that multiple times depending upon how many subsets we have to evaluate, right. So you will have one, in this case there are only two possible split points. So you will have a cross entropy value which will put youth on one side and the other two on the other, and similarly you will have an evaluation for this part. So that is just for cross entropy variable. Then you do the same for income, student and credit rating, and finally among all of those whichever is the lowest you pick that as your attribute and split point. Is that clear?